Welcome to our video lesson on the percent of a percent. And when you think about that, it sounds kind of confusing, but it's questions. We'll go through several examples and hopefully you'll get an idea of what that is. Okay, so let's start with an example. Only about 29% of the total surface area of Earth is made up of land. So if you think of the globe or a map of the Earth in your head, only 29% of it is made up of land. The rest would be water, probably just water. And only 38.4% of this land area is agricultural land. So that means that of 29% of the Earth's surface, all that land, only 38% of the land is agricultural land. Approximately what percent of Earth's total surface area is agricultural land? So this is a percent of another value. And so it's a percent of a percent. So it's 38.4% of 29%. So to figure out the total, we have to think of the total surface area on Earth as 100%. So we have 38.4% of land area that we can use for agricultural land, but that is 38.4% of the 29% of total surface area. So the 38.4% is the percentage that is agricultural land, and the 29% is the 29% of the total surface area of Earth. Then we need to figure out what this actually would be. So I'm going to convert both these percentages to decimals by moving my decimal over 2 spots or dividing by 100. So what I would get is 0.384. Now, and then 0.29. The word of in math represents multiplication. So whenever you see of, it usually can be replaced with a multiplication symbol. So in this case, it'd be 0.384 times 0.29. And when you multiply that, you'll get 0.11136. And then we're going to multiply that. We want this to be a percentage, so we'll multiply it by 100 to go from a decimal to a percent. And that means that we're moving the decimal spot 2 spots to the right, so 1, 2. What we'll end up with is 11.136%. So that means approximately, we want to round this to 1 decimal place, be 11.1% of Earth's surface is agricultural land. Now that's how we calculate a percent of a percent. Let's do another example. The number of students at a school is currently 1,200 students. School officials predict that the number of students will increase by 9% next year, but then drop by 12% the following year. Drop is important. How many students will be at the school 2 years from now? So there's several ways we can do this. The first way is we can do it 1 year at a time. So let's start by looking at next year. So it tells us that the number of students will increase by 9% next year. So that's the only part we're going to look at. And that means that the increase next year is equal to 9% of the students this year, right? Because it's going to increase by 9%. So that'd be 9% of how many students we have this year, which is 1,200. And then we need to convert this percentage into a decimal. So I move my decimal, I'm dividing by 100 or moving the decimal 2 spots to the left. And I get 0.09 of 1,200. Now remember, when we see the word of, we know that that's going to be multiplication. So I can replace the of with multiplication. So then I need to multiply 0.09 times 1200. And that will give me 108. Now does that mean there's 108 students there next year? No, that means that the increase, how much the population will increase by, is 108 students. So then to find the total number of students, we need to take the number we had before and add the increase. So that would be 1,200 plus 108, which would be 1,308 students. So that means that next year there will be 1,308 students. However, the question wasn't asking how many students there'll be next year, it's asking how many students there'll be 2 years from now. And now we need to look at the second part of the question. I'm going to move on to the next slide just so we have it, but let's know that after, so next year, we'll have 1,308 students. Okay, now let's look at what's going to happen 2 years from now. So 2 years from now, it says it'll drop by 12% the following year. So we need to figure out what that means in terms of our student body, our student population. So it'll be 12% of next year's students. So 12% of next year's students, and that will be 12% of 1,308. So that would be 12% times 1,308. Then we need to convert this percentage into a decimal. So I have my decimal point and move it 2 spots to the left. And I end up with 0.12 times 1,308. Then I need to multiply those together, and I will get 100. Oh, I'll get a big long decimal. So 0.12 times 1,308 equals 156.96. I have a question for you. Can you have decimal 9/6 of a student? No. So we need to round this. So to round it, we look at one spot after where we want to round it. So we look at this 9, and because the 9 is greater than or equal to 5, we're going to round up. So we'll get this is 157 students. And I should make this an approximate sign instead of an equal sign. So approximately 157 students. Now we actually have to figure out how many students there will be. So we're going to start with next year's students minus decrease. And that will be equal to the total. So next year's students is 1,308 minus the decrease of 157. And then that will give me 1,151 students. Oh, and I should put approximately, because this is no longer an exact answer. So that means that 2 school years from now, there'll be approximately 1,151 students. Now, there is another way to do it. Actually, there's 2 more ways to do it. Let's take a look at another way, which you might prefer. Okay, so it says that the number of students next year will increase by 9%. And what that means is that our number of students next year will be 100% of the students we have this year plus 9%, or 109% of how many students we have this year. So what we can do is take out some steps by saying the total number of students for next year will be equal to 109% of the students we have this year. So that will be 109% of our 1,200 students. And again, we're going to convert this percent into a decimal by moving my decimal place over twice. And I get 1.09 of becomes times and 1,200. Now when I do that, I get 1.09 times 1,200, 1,308 students, which looks familiar because that's what we found before. We can use the same logic for the following year, so that it drops by 12%. Well, a drop by 12% means we have 100% minus 12%, which would be equal to 88%. So we're going to look at total number of students. This is year 2. And up here, this was year 1. Our total number of students will be equal to 88% of the year before. So again, we have 88% of our 1,308 students. 88%, we're going to write it as a decimal by dividing by 100. So we move the decimal over twice and we get 0.88 times 1,308. So we're going to multiply those. And we get 1,151.04, which should look familiar. Now we need to round our answer because we can't have 4/100ths of a student. So this becomes 1,151 students. That's a different way you can approach the same problem. There's one more way we could do it. This last way kind of combines what we've done in the previous 2 methods all into one. So an increase of 9% means the number of students next year will be our 100% plus 9%. But then the following year, or 109% of this year, the following year it will be 100. So that's this year. Next year, it will be 12% less, so a 12% decrease, or 100% minus 12%, which we know will be 88%. So we can combine these percents by saying total number the following year is equal to 88% of the number next year. So that would be 88% of 109% of the number this year, because that's what makes up the number next year has been divided into this part here. Well, then I know that it will be 88% of 109% of the number we have this year, which is 1,200. So then I'm going to convert my percentages to decimals by dividing by 100 or moving my decimal over twice and replacing ofs with multiplication signs. Again, divide by 100 or move the decimal over twice. Of 1,200, and then you can do this multiplication and you'll get a longer decimal. So 1,151.04, which we can't have 400ths of a student, so it's equal approximately to 1,151 students. So there's 3 different ways you can approach the same problem. All of them work. You can start with whichever one makes the most sense to you and go from there. That's all for our video lesson today. If you need any help, please ask me. I'm here to help you. That's all for now. I'll talk to you later.